Hello, my name is Andrew Perry, and today we're going to be going through a quick interview question for my CSE 212 Programming with Data Structures class. In this, we have a little hypothetical scenario where we're helping develop a garden simulator game, and in the game, we go around and discover piles of seeds. We pick up the seeds, put them in a bag, and then we can replant them later. But the catch is when we replant them, they have to kind of go from the top down. So we can't get to the seeds at the bottom of the bag because they're being covered by seeds above it. And so, okay, with that in mind, we're going to answer some questions. All right. So, first question here is what would be the best data structure to model the behavior of the supply basket? Now, in this class, we've already been talking about a couple of different data structures, queues and stacks, namely. And I think a stack would be the best because it kind of already has the inherent behavior that you'd expect from this kind of this kind of operation, this basket, supply basket. So here I drew a little model of the supply basket, and we have all these different seeds lying around, and we can pick them up, put them in the basket, and then as you can see, as we place them in the basket, each new layer is covering the one below it, meaning we can't get to it until we remove them again to get to the layers below. Now, yeah, and with a queue, I guess you could imagine a hole at the bottom of the basket there, in which, as things are placed in, they would come out the opposite end. Okay, what is the time complexity for adding new seeds to the supply basket? So, as we can see, for adding each item to the supply basket, it doesn't depend on what's already inside. It's independent of that. So we would write that as an O of n uh, time complexity. Or not O of n, my apologies, of 1. So it's not dependent on how much stuff is already in the bag or basket. It already um, does so, or it does so independently. Um, what is the time complexity of removing seeds from the supply basket? That it's going to be also O of 1 because it's not dependent. It doesn't change based on how many things are in the basket. It's always one operation, or the same number of operations. And then the time complexity for checking to see if the basket is empty, that's actually also O of 1. Um, Now, if we were checking to see the quantity of items, like how many different kinds of seeds we have, that would be O of n. But in this case, it's O of 1.